Now, as you read above and saw in the previous video, pressures from the environment can alter a population's heritable traits. So selection pressures can affect the central tendency of the data as well. Here we see directional selection, where due to pressures, extreme traits are favored over the normal traits. In this lab, we will be examining gall flies and the galls or homes that they form in goldenrods. Now, wasps tend to predate the smaller galls, and birds tend to predate the larger galls. So in this case, if there were more wasps in an environment, the galls that formed larger galls would survive much easier compared to those who made smaller galls. This would push the population towards having more larger galls. The central tendency of this data would be affected here, since the tendency is moving towards larger galls, and the mean, median, and mode would have to realign to reflect the data. The variance in this case would remain the same. And here we see an example of stabilizing selection, where the pressure selects against both extremes and results in a stabilization of the population. This could be seen in a population of gall flies that has an equal amount of wasp and bird predators, making the flies that stick to the extremes less likely to survive and eventually pushing the population to an average size gall. Here, the central tendency of the data would become much more focused, and the average of the data set and the mean, median, and mode would become more reflective of it. In stabilizing selection, the variance would also be reduced since the data would be favoring the average and eliminating extremes. And here we see disruptive selection, where the pressure selects against the mean and results in a bimodal distribution of the population, with the central tendencies being towards the extremes. The central tendency of the data would be split to both extremes, and the median and mean would still lie at the center of the data set and therefore would not be reflective of the central tendencies. In disruptive selection, the variance would increase because both extremes are favored.